So, a very warm good morning, good afternoon, and good evening to one and all joining from different parts of the world. I am Dr. Neha Tiwari, and I welcome you all as a host of ICICT 2022. The authors and invited guests, I welcome you all to the technical session 3E. On behalf of Global Research Foundation, it's my great privilege to welcome you all to the 7th International Congress on Information and Communication Technology through Zoom. Further, as you all are well aware, we have been facing new normal situations while overcoming the pandemic. Hence, the conference has been shifted to a hybrid mode. We are very thankful to everyone present on this platform to go along with us digitally for the conference in these unpredictable circumstances post COVID 19 and making this conference more productive. Also, we wish everyone and their families a protected time. We hope you all will enjoy 2 days of the knowledgeable and interactive digital sessions. There is a special note for the presenters. You will be given 10 to 12 minutes for the presentations and 3 minutes for question and answers. On 10 minutes, I'll raise a gentle reminder. I request while the presentation is going on, other participants kindly be muted. There is another request to all the participants that you all stay connected with us till the closing remarks. Just before we get started, I would like to introduce you all to the chair of the session, Professor M. Shamim Kassar. Dr. M. Shamim Kassar is currently working as a professor at the Institute of Information Technology of Jahangirnagar University, Savar, Bangladesh. He is an associate editor of the Cognitive Computation and IEEE Access Journal, guest editor of Brain Informatics Journal, IJACI and Cognitive Computation Journal. Dr. Kassar is a lifetime member of Bangladesh Electronic Society, Bangladesh Physical Society, and many others. He is also a senior member of IEEE USA and ICE Japan and active volunteer of the IEEE Bangladesh section. He is the founding chapter chair of the IEEE Bangladesh section Computer Society chapter. I make it more specific. Thank you, sir, for chairing the session. Can we start the paper presentations now with your consent?
Yes, please.
All right, so thank you so much. So with that, I begin my first paper presentation by calling up George Yosifov from Bulgaria. I hope I pronounced your name correctly. So
Thank you,
I
Nisha.
request you to start your paper with the title Review of Urban Traffic Detection Approaches with Accent of Transportation in Sofia, Bulgaria. Please start with your presentation.
Thank you. Are you able to see my screen?
Yeah, that's visible.
Thank you very much. Dear Chair, dear moderator Nisha, dear guests, thank you all for joining. We would like to present to you our joint work for me and Associate Professor Milan Petrov. The title of the topic that we would present to you is a review of urban traffic detection approaches with accent for transportation in Sofia, Bulgaria. We are part of the Faculty of Informatics and Mathematics in Sofia University, St. Clement Ohridsky in Sofia, Bulgaria. Hope you enjoyed. So a brief overview of what we are going to discuss today. It's a very technically light topic, so we'll just discuss a little bit about how Sofia city looks in terms of its traffic, its growth, We would then proceed by discussing why a traffic analysis is important, discuss different types of traffic analysis and possible categorization of it, and from that draw our conclusions. So I know that we are people from different countries, obviously different continents as well. So a bit of overview about what is Sofia City. So Sofia City is a European capital of Bulgaria. It's the largest settlement in the territory of the Republic, and it has a population of 1.3 million people. So although the country as a whole is shrinking, unfortunately, as a population, Sofia, on the other hand, is growing because a lot of people are migrating to the city, and it has best birth rates amongst the whole country. So forecasts are saying that by the year 2030, the population in Sofia would increase by another 2% or 25,000 people. And we know with the growing population, there is also another thing that is growing, and this is the number of vehicles that we see on the roads, which has almost doubled in the last 9 years, from roughly 46,000 to 462,000 to 833,000, which does not include the transit vehicles that pass through the city. This is a graph from the National Statistical Institute, which presents roughly the newly registered vehicles year by year. So you can see this is a percentage, and roughly each year they're right below 8% of newly registered personal vehicles for the use, which is reflected to that growing number. And of course, not only personal vehicles are being used in the city, there are also the growing number of public transportation vehicles, and that is like 586 buses are servicing the population, which is with what 155 more from what was it in 2009. Roughly 95 routes, 31 lines are served by private contractors, 33 kilometers per year, and 360 million passengers uses public transportation each year. And they cover roughly 1.5 million meters, of bus network. Coverage of the transportation in Sofia is roughly looking like this, red lines being the buses. And so why am I saying all of this? Obviously, a lot of traffic is going in the capital, a lot of cars, a lot of transportation, but we also saw in the previous years that the traffic and the lack of it can be great savings. So, for example, this is data for a UK company called INRIX, which estimated that for the year in the pandemic, they costed the savings that the United States acquired from not having that much traffic on the roads was nearly 1 billion. And also the rest, the numbers for United Kingdom and also Germany, pretty impressive as well. Another importance, if measuring traffic, is obviously the CO2 emissions and air pollution levels, and this monitoring is giving the ability of administration and to make data-driven decisions of how to optimize the traffic. Should we have roundabouts? Should we have overpasses? What should we do to make the free flow of the traffic as easy as possible? Again, from COVID times, the delivery services are also growing, and they need an optimized software for routing them through the parts of the city that have the least amount of traffic, so they can easily reach their destination. Data collection is also obviously very important. The ways that we gather data, the ways that we store data in a manner that is secure, and preventing data leaks. There is curious examples, for example, Fitbit is unintentionally uncovered some locations of secret military bases because they have smart bracelets, and were used to publish this data in a global map. And metadata can also be dangerous or used for targeting individuals. And according to this, the European legal regulation, seeing this and having this in mind, has created the so-called GDPR, which obliges all entities who store data to have legal reasons for doing this, and also to keep it encrypted, keep it deanonymized, and keep it as long as it's needed and not more. So traffic congestion, traffic monitoring, these are all topics that have seen growth in publications over the years. And what we did was concentrate on the 4 major types of gathering traffic data. And this is smart devices, phones, GPS in vehicles, video surveillance, and positioning data in public transportations, where the last one is the one that we are, me personally, probably interested in doing more research. Also, this diagram shows that all of these can be used to play together enough data to give a multidimensional view of the traffic. So phones, everything is good with them. They have a lot of volume of data is very big, but the problem there is that it's probably most corporate owned, and there are secure implications for the data security there. GPS in vehicles, this is something very similar to the mobile phones, one example, but here the GPS is inside the vehicle. Volume is a little bit smaller and shares many of the pros and cons with the mobile device one. Video surveillance, this one is an interesting one. It can also be used for multi-purpose things, for example, not only to measure the volume of the traffic, but also to check if the vehicles are going in a one-way street, if they're parking in forbidden zones, if they're speeding, if they're improperly overtaking. All those things can be monitored, and there have been done large-scale experiments in London from their JamCam monitoring system for detecting pedestrian vehicle traffic. It's more cost producing because it uses more complex algorithms, and it's more computational power, and it has to account for different things like lighting, weather condition, etc. There is also privacy concerns there. Public transportation positioning, that's an interesting one, to use the GPS in the buses themselves as probes in traffic and to determine the road situation only by inferring from that probes. There is also, you can monitor the unique characteristics compared to other vehicles in the road. And a lot of data is not, there aren't a lot of data in the open for this kind of like public positioning data of buses. But United Kingdom comes to the rescue once again, because Edinburgh has published a data set from their city and their public transportation with data like this. It's more
Sorry
short.
to interrupt. You just have last 2 more minutes to
That
sum
would be
up.
enough. Yeah, I'm almost finished. Thank you. So small categorization for the possible approaches. So we can see that the availability of the smart devices is high, cost is low, but privacy concerns are very high, and position from buses have a low privacy concerns. We don't know who is traveling, and the cost is low, and the availability is moderate. There is also, you can see the others highlighted there. So in conclusion, Sofia is a modern city. It has all the grounds to use a multifaceted approach to detect traffic because it has a high coverage of transportation network. It's well connected with the internet, and there are a lot of vehicles and a lot of data that can be approached so that decision makers can take action, make decisions, and improve the traffic. Some acknowledgements. And yeah, that was it. Thank you. Any questions would be very much welcome.
Thank you so much. Any questions from the participants? Over to you, Professor Shamin.
Georgie, it was a nice presentation. I have only one query. Do you have any plan to implement urban traffic detection approaches to reduce the traffic jam or any other mishap?
Yep, thank you for the question. We already have some research in that area. Like I mentioned, the thing that is personally most interesting to me is the using the data of the buses themselves to detect traffic, because it's very cost efficient. It's majority of the buses have already equipped with the GPS receivers, and we have done some experiments to show the high correlation coefficient between the time spent of buses in particular length of, let's say, road to the number of vehicles on the road as well. So we can extrapolate from just the time that the buses have spent in a particular road stretch, the volume of vehicles that are passing through that in that particular time frame. So again, thank you for the question. We have some researches. We have shown that this can be used and can be used to show good results.
Are you using any kind of crowd mobility pattern for detecting urban event or urban traffic mobility?
We did a statistical analysis of the data that we have from Edinburgh City, and what it showed is that the actual times that we were recording were in a logarithmic normal distribution, which is very nice property to have. So the logarithm of this of the time forms a natural distribution, or Gaussian distribution is also known. So we can use this statistical information to infer what is the volume of the traffic. Yeah.
Thank you, Georgie. Up to the hand.
Thank you very much. Yeah. Stopping the sharing now.
Okay. Thank you. So with that, I invite the next presenter, Hala Al-Mazrua from Saudi Arabia. Her paper title is Cloud Robotics Knowledge Sharing Survey. I request you to strictly abide to the time limit. I hope I'm audible to you. Yeah?
Yeah, I can hear you.
You
Can
can
you
start
hear
with
me?
your presentation.
Yeah, I will try to
Come
share
ahead.
the screen.
All right.
You can all see my screen, right?
It's visible. Yeah.
Yeah, that's good. Yeah. Okay. I'm Hala Al-Mazrua, a master's student in King Saud University. I did this survey as a coursework for cloud computing course with Alia Umay Al-Hanoud. What motivated us to do the studies? We found out that we need in high-level review studies that support research and survey in cloud computing, especially in knowledge sharing between the robots in the cloud. Also, we need to guide other researchers and focus on the gap in the knowledge sharing field in the cloud robotic. Also, we need to show new technology and tools that are used right now in cloud sharing field. since cloud robotic is very broad titled and there is many multiple studies that aim to enhance different targeted parts in the field, but survey available are not enough to direct future work. Based on our knowledge, there are no previous survey done in knowledge sharing field. So we had done this survey. Our study objective, we reviewed studies in major computing databases to answer these three questions. What areas are covered by cloud robotic research? What are the technology and framework used to enable knowledge sharing in cloud robotic? What are the research challenges in cloud robotic knowledge sharing? Introduction, a small introduction. I want to take so much time. Okay, cloud robotic, in brief, it's robotic that are connected to computer or cloud to exchange information or data, send or receive command from other robotic. So we take advantage of local cost for computing power and widespread internet connectivity and enable for more human and
I don't think the slide is visible to everyone.
The slide is not
Is it?
visible.
Yeah, now it is.
Oh,
But the
okay.
next slide, I think you changed the slide, right?
Yes, introduction. Is it not visible?
The next one, introduction slide is visible.
Yeah, yeah.
Visible.
I'm introduction right now.
Slide in between.
What?
Did you
Can you
change
please
this
move
slide?
to the next slide?
No, I'm introduction. Robotic connected to external computer
Okay,
cloud.
you
Do you see
haven't
the
finished it
specs?
yet. All right, okay.
Yeah. Okay. Thank you. Okay. Also, it's communication network that connect group of robot for wired or wireless communication, so they can share knowledge between each other and take advantage of previous knowledge that other robotic has, and lower the time for this robot to learn and take his already knowledge in this robot in this robot. So knowledge sharing is considered a branch of artificial intelligence. Okay, for the lecture review, it's kind of a lot, but I will summarize it in 3 points. The lecture review, we did classify it in the 3 categories: cloud robotic between human and robot, or between robot only, or hybrid between robot and human also. We primarily looked at article published between 2013 and 2021, so we can make it more recent. There is old studies, but we try to discard them since they're old. We want this survey to be follow the current trend and limitation and the current challenges in this phase. Okay, in the previous studies, the result of we found out that many of them that we did the experiment using simulation or real life situation or both, but most of them use real life simulation. We thought most of them used simulation, but we were shocked to find this one. And most studies use artificial intelligence to gain knowledge without humans. So the robot can take knowledge without human interaction or in the studies. Also, previous studies examined with different environments. Most studies were conducted in real life and some were in simulation. Also, the study that use hybrid
Which slide are you on, Hala? Your slide isn't visible yet.
Lecture review is not visible.
Literature review?
Yeah.
Can you please move to the next slide?
Introductory trend.
Okay, yeah, thank you.
Yeah, okay, thank you. We found out that the study that used human with the robot gave the best accuracy and the best performance, except the study that didn't use humans. So I think it's recommended to use human. For the interested trend and the tools that are mostly used in cloud robotic, we took this following tool. I will summarize in each one. Robota. Robota is an open source framework which is built upon RoboAuth. Most of them, I will take a small. Most of the tools here, they are built up atop each other. They took advantage of this tool and they built another tool. They still made it an open source. You can also improve it more. Like RoboEarth is the first one. Most of the tools here took advantage of it since it's open source and used an API. Rabaya took advantage of RoboEarth. Also, RoboBrain took advantage of RoboAuth. iOS RoboMaker, Amazon. It's open source robot simulation. What I found it interested in Amazon, the communication framework between robotic. It's their own framework, a grasping connector. They didn't use an API or WebSocket or publisher subscriber. They built their own communication network for this tool. Also, Google, they use RoboFleet connectivity for the robot to connect with each other. Also, we found out most of the tools took advantage of reactivity, which they have entered. Also, RoboEarth Freedom Robotic did not provide any information that indicate the robot reactivity. Robot activity, is it shut down? How much time will take to get up again? Also, we found out fault tolerance is considered the most critical part in cloud robotic. Most of the tools provided, except ROS, OpenAce, RoboEarth, they didn't provide fault tolerance. If any robotic crash, it has to be human to go there and restart the service again from zero. Okay, most of it. Conclusion and future work. We recommend author in the future since the previous one found out if you use hybrid human with robotic, it provide the best performance. We recommend you still go this path. Don't discharge human from the environment. Also, AI, it enrich the cloud robotic, especially in knowledge sharing. Also, we found out cloud robotic, we didn't find many papers, so we need more studies in this field to raise the level of performance in task. Also, to address the challenges in the communication for robotics, since API is not that great as a communication protocol. So we need more studies, since Amazon, their own communication framework, they didn't publish how they did it. So it's not open source. So we don't know how to use it and use it in other robotic. Okay, thank you. Any question?
Thank you so much, Hala. I now request Professor Shamim to take over the mic. Thank you.
Thank you, Hala. It was nice work.
Thank you.
I mean, I have just two concerns.
Okay.
The first concern is, I mean, in cloud-based robotic system, always, I mean, depends on network issues, right? So there is a possibility that high latency can make your application slower, right? And also, any kind of fault in the network can create problem. So how you can handle this issue?
That's why when I compared the interest here tools, I pointed out that fault tolerance is the most important criteria. Most of the tools support it, but I found that like ROS and RoboEarth, they are a starting point for all knowledge sharing tools. They don't provide knowledge fault tolerance. So they need to provide fault tolerance for the tools, but most of them provide it. but not all of them, especially ROS. I was shocked they didn't find it since ROS is the most popular one, but they didn't support fault tolerance.
And the second thing, I mean, sometimes the computation must be offloaded to the cloud, right?
Yeah,
From the robot, the computation, sometimes we need to upload that computation to the cloud, right? So
yes.
how do you, in your opinion, how do this could be done?
Uh, I don't know what's the best one. When I Google, when I search, I found that Amazon has the best communication with the cloud. But when I try to solve the search, what communication framework they use, it didn't say how. So I don't know how they will do it. But API, most of them use API. But I think API is not that great. It has many issues, especially in the HTTP request, timeout, body size. So I don't know how they do it, but I wish Amazon, they say how they build their own communication, since compared to any other tool, it has the best performance in knowledge sharing between robots and how the knowledge moved between robots, the fastest one.
Thank you so much.
Thank you.
Thanks both. That was an interactive discussion, we would say.
Thank you.
Yeah. So I now call upon Myron Daryl Monfalcon from Philippines.
Hello, everyone.
He's Yeah, hi. So he's going to present his ideas on sign language recognition of selected Filipino phrases using LSTM neural network. Over to you, Myron.
Is my screen visible now? Hello?
Yeah, that's visible.
Okay, thank you.
Yeah, it's visible.
Good day, everyone, from ICICT 2022 London. I'm here to present the paper ID 475 entitled Sign Language Recognition of Selected Filipino Phrases Using LSTM Neural Network. So I am Myron, and I am from National University, Manila, Philippines. And here are my co-authors, Mr. Gerald Padilla and Mr. Ramon Rodriguez. So this will be the outline of the presentation from the problem, followed by the known sign language recognition approaches, our approach, the results and key findings of our study, and finally, I'll talk about the conclusion and future direction of our study. Now more than ever, it is clear that communication is an essential part of our life. Through communication, we are able to connect with others, share experiences, thoughts, and wants. And communication is a vital part of our society. However, there are certain groups of people, the deaf community in particular, who are incapable of the conventional way of communication, and for them, communication is their number one struggle. So in the Philippines alone, 1.23% of the total population is either deaf, mute, or has hearing impairment. And the deaf community has been incredibly marginalized by mainstream hearing society here in the Philippines. So with the help of sign language, it has contributed in bridging the gap between the deaf community and the hearing majority. So the Republic Act 11106 declares FSL or Filipino Sign Language to be the national sign language, and it also mandates FSL to be used in all transactions involving the deaf. However, and despite the implementation of RA 11106, majority in the Philippines do not understand FSL, and learning it requires training. As a result, it has led to an undeniable communication gap between the deaf community and the hearing majority. With this, the continuous advancement of technology, and one of the innovations is sign language recognition. So it is a collaborative research area which involves pattern matching, computer vision, NLP, and its objective is to create an algorithm in order to identify or translate sign languages. So for the past decades of exploration on SLR, the research has achieved significant milestones. So in this paper, entitled Sign Language and Computing in a Developing Country, a research roadmap for the next 2 decades in the Philippines, they stated that the Philippines is poised to make an impact on sign language recognition and computational linguistics in the next 20 years. However, fast forward to the year 2022, research on Filipino Sign Language recognition remains limited. And these are the following factors. First is there is no publicly available dataset, and developing FSL recognition system requires different expertise. And another one is that it requires an extensive amount of data and analysis on FSL. And now let's briefly talk about the sign language recognition approaches and the literature that we have reviewed in our paper. So there are actually three established approaches in the sign language recognition field. First is the glove-based approach. So basically it uses gloves equipped with sensors, and one of its advantages is that it can accurately acquire gesture-related data. And however, its disadvantage is that most proponents are expensive. Another approach is through visual-based technique. So it is widely used, and it only utilizes web camera. And its strength is that it can capture facial expression, hand gestures, and even body movement. So finally, the hybrid approach, which is the combination of both architecture. So although this approach is promising, the challenge is that the complex computational setup and requires developing prototypes. And these are the papers that we have that have developed an SLR system for FSL. And since we don't have a lot of time to summarize the reviewed literature, most of these papers utilize visual-based and glove-based approach. And the papers mostly focus on the isolated word recognition, such as Filipino static words, alphabet, and number recognition. On the other hand, in our study, we focus on continuous FSL recognition using visual-based and deep learning. So the main objective of our study is to create a continuous SLR system, and it must have the following properties. First is it must be robust. It must be integrated with non-manual features. It must be time efficient, and lastly, it must be designer independent. And now in this section, I will be talking about our methodology in building the continuous SLR system capable of recognizing the sign language of Filipino phrases. So for the data collection process, this is a 4-step process. First, we invited the signers, and we have invited 3 signers. So the signers that we have invited perform the 15 Filipino phrases in front of our device, and they utilize a web camera. For the data collection process, we are able to obtain 30 videos per phrase, and they involve kumusta, which is how are you, okay lang, it means it's okay, hindi okay, it means it's not okay, magandang araw means good morning, and the rest. So that's the 15 phrases that we have, which is the scope of our study. For the data collection process, this is the documentation process. They are a FSL signers. And for the framework that we have utilized, so from the collected video sequences, it went undergo feature detection, feature extraction, and be pre-processed, and then it will be trained using the long short-term memory or LSTM neural network. And then the output is the corresponding translation of the sign language. So in the feature detection, we utilize media pipe holistics. So it is a new technology. I think this was developed in the year 2020 by Google. So it is an open source technology for real-time and simultaneous access to key points of humans' pose, face, and both left and right hand of the user. So we utilize this because of the capability in providing key points accurately in real time. So in this feature extraction, we have extracted features from both manual and non-manual features. So why LSTM? So we have utilized LSTM because of its memory capacity, which is highly advantageous in continuous SLR models. Also, it utilized time series or sequential data, and it is very good in duration gaps in performing different gestures in sign language. Also, LSTM can tackle vanishing gradient problem usually encountered using traditional based neural networks. So in our study, we have conducted 3 experimental setup. First is the model evaluation. So this just aims to evaluate the model. So we have used a cross-validation technique of 80 to 20%. 80 for training set and 20% for the test set. So for the evaluation metrics, we use accuracy, precision, recall, and F1 score. Another experiment is the feature importance analysis. So in this experiment, our aim is to rank the importance of each facial feature. So by isolating if it's each of the facial features, such as eyebrows, eyes, and mouth. And lastly is the indoor and outdoor experimentation. So in this experimentation, we aim to investigate the generalization capability of our model on outdoor and indoor setting, and also on different signers. So want to check its robustness and if it is signer independent. Now for the recorded demonstration using the SLR system. Let's give this I think 30 seconds. So as you can see in the demo, the person in front is performing the sign language, and there is I think a 0.2 seconds delay, and there will be a prediction on the performed sign language. So maligayang kaarawan is happy birthday. So walang anuman is welcome. So yeah, that's it for the demo. For the results and discussion, in the first experimentation, the LSTM model, the 5 setups for LSTM model, the best is for the with 4 LSTM layers and 3 dense layers. It has produced 94% accuracy, and the rest of the figures here supports the LSTM, the best model of LSTM. For the feature importance analysis, without all the facial features, the average accuracy is only 47.4%, while complete facial feature produced 71.1 accuracy. So in terms of ranking the facial feature, the most important is eyebrows, followed by mouth, then the eyes. So the analysis shows that facial features are an important component in predicting FSL, thus they must be included in developing SLR systems. For the indoor and outdoor experimentation, for the indoor is 70.74%, outdoor is 74.02%, and for the summary of the experimentations, that's just it. And now for the conclusion and future direction of my study, the SR system developed is capable of recognizing 15 continuous Filipino phrases. The model evaluation has shown an impressive result, wherein the average accuracy is 94%. And also in the experimentations conducted on 10 participants, the SLR system has obtained 72.38% on the average on 2 trials on indoor and outdoor experimentation. And based on our analysis, we can say that the developed SLR system is robust as it can recognize FSL gestures regardless of the background or environmental changes. Also, it is time efficient with near real-time prediction time and fast training. Additionally, the SLR system is capable of detecting non-manual and manual features. So manual features are the hands. On the other hand, the non-manual are the facial expression. Finally, we can say that the system is signer independent as it can recognize Filipino phrases on different signers. So in the 10 participants implies that it can be used by different signers. For future direction, we want to have more data, and more data will be collected to enable conversational SLR system with larger FSL vocabularies, further improvement of the UI, further optimization of the SLR system, and finally, one of our goals is to embed this model on the mobile application. This way, this will be applied and be more convenient to the deaf community. So with our study, we hope that we are one step closer to the vision of helping the deaf community have more opportunities in life. And that's it. Thank you so much everyone for listening to my presentation for the paper ID 475 entitled Sign Language Recognition of Selected Filipino Phrases Using LSTM Neural Network. Again, I am Myron Daramil Falcon, and thank you so much. If you have questions, please do so.
Thank you, Myron.
Thank you.
Excellent work. But I have one concern. I mean, we have seen for image analysis, many of the people use CNN, and that's why we have observed for other language like Egyptian language, Bangla, Arabic, people are using LSTM with CNN.
Yeah.
Why you have chosen only LSTM?
Okay. So actually, we have a paper only focused on LSTM, but we have also reviewed a paper which stated that ResNet or CNN can also be used for time series data. So we just want to know if ResNet CNN can also be applied in this kind of research field. But on our results, we were able to determine that LSTM has outperformed because it is more capable for time series data.
Okay. The second question is, I mean, your data set seems, I mean, the volume is relatively lower, right? Because you are considering a particular age group people.
Yeah.
So for sign language, if I mean the people with a different age group, their movement patterns could be different. So this is a challenge. How do you handle this challenge?
For different age group, actually, in our participants in the for the indoor and outdoor experimentation, the participants are age ranges that from 21 to 50 years old. So we can say that it can be solved by having more participants. Thus, we can have more conclusive conclusion or results from that point of view. I think. So
Thank you, Myron.
Thank you. I hope you understood my study. Thank you.
Thank you so much, sir. Thank you so much, Myron, for that wonderful presentation. I now call, just give me a moment. I think there is, all right. So I now call Marina Tolmak from Ukraine with her paper, Organization of Training in the Art Education Institution in the context of the COVID-19 pandemic. I think this is the very first paper in this session that's directly targeting COVID-19 pandemic. So we hope we'll get some solutions in a particular domain that she's addressing. Marina.
Hello, all from Ukraine. Let me share my presentation.
Sure. And I request you to please keep the time limit of 10 minutes in mind. Thank you.
Okay, I will try. Let me introduce myself. My name is Marina Tolmach. I am a Deputy Dean of the Faculty of Distance Learning at the Kyiv National University of Culture and Arts. And I want to present our shared study with my colleagues. You can see this study introduced how the COVID-19 pandemic affected higher education and how it can reduce the negative impacts of the pandemic and respond to future challenges with use of ICT. We analyzed the problems and consequences related to the educational process in Ukraine in the condition of quarantine restriction. I want to present the experience of Kyiv National University of Culture and Arts in adapting the educational process to today's challenges. I will talk about the main direction of the university work on reducing the consequences of the pandemic and ensuring the stability and flexibility of the educational process in the conditions of quarantine restrictions. Now, we know that the pandemic has led to some significant change in education worldwide. And the introduction of distance learning in higher education institution has revealed a number of problems. There are digital inequality, mental health problems with mental health, and problems with educational outcomes. Next problems in Ukraine is a lack of systematic support for recommendation and clarification from our Ministry of Education and Science. And the most significant factors is lack of previous distance learning experience. Most educational institutions were not ready to move to distance learning. Several among educators show a lack of experience on distance learning, digital skills, and so on. We have positive dynamics in this issue, but we still need to make efforts to improve the situation. And the transition to distance learning has become a big challenge for the field of art education. We have the results of the All-Ukrainian survey in experience of distance learning and work during quarantine in art education. The results demonstrate the teachers' need for the development of digital skills and fairly high level of motivation to master digital technologies. In this slide, you can see the short results of this survey. And we can see that the vast majority of art schools for the first time faced a distance challenge, but significant numbers of teachers already had experience in isolated cases applied to various form of distance learning. A separate issue concerned the use of digital service for distance learning. In most cases, teachers chosen service that provide only video communication and file transfers. This suggests the need to implement a digital literacy program for teachers of art schools. Let's talk about our experience about the path of the Kyiv National University of Culture and Art. It is a modern educational corporation, a national scientific and cultural center. Our students study in such specialties: choreography, musical arts, performing arts, film and television art, design, information and library studies, cultural studies, etc. Each of the specialties has its own characteristics that must be taken into account. You can see the long way in transition to distance learning for our university. We can divide into several dimensions. The development of technical infrastructures and accessibility, the development of digital competence of participants of the learning process and readiness to use distance learning technologies, and field of study. Arts and classical specialties require different approaches. We have come a long way in finding the best option to continue our studies in the pandemic. During this time, we tested new application services approach to the organization of training in art education online. And you can see the system of online learning. We use synchronous and asynchronous mode of our training. We use service for video conferencing. We use Google Workspace for education, and we developed a learning platform on the with the Moodle technologies. Our learning platform, our students have access to the learning materials. We developed it and help our teachers to adapt their materials from offline to online. We developed the information resource for our teachers when we use the instruction, text, and video and recommendation for use of distance learning technologies. Our faculty analyzed different service of video communication software, and we stopped on the Zoom because it apply our requirements. We can provide online classes up to 300 students. We have an administration panel with statistics. We have a technical support, and in addition, we have high fidelity music mode, and our musicians, students of musical art, they use this mode in Zoom for better quality of audio. So additional approach to make better make our educational process better and more flexible, we developed a new approach to the formation of training schedules, which allow us to react quickly to change in the epidemiological situation. Additional requirements for scheduling have been introduced. You can see it on the screen. And early planning in compliance with these requirements make it possible to apply different scenarios. For example, when the epidemiological situation worsens, to reduce the number of contacts by transferring lectures online, or when cases of COVID-19 are detected, providing conditions for continuing the educational process completely online for individuals, academic groups, or faculties. The introduction of digital technologies in the educational process should be accompanied by adequate training of teachers who are ready to interact and cooperate in the latest digital environment. This has become a challenge for all parts of the art education systems, for all participants in the educational process, administration, teachers, parents, and students, and has highlighted the need to ensure a sufficient level of digital competence of teachers of our education institution. In our university, systematic measures have been organized to improve the skills of teaching staff in the field of distance and blended learning methods, the development of their digital skills. We used the international experience in the development of digital skills. In particular, the experience of the Erasmus Plus project, DICOMFRA, digital competence framework for Ukrainian teachers and other citizens.
Marina, kindly conclude your presentation.
Okay.
That's 2 minutes. Yeah.
Few slides and I will finish. Now you can see how we dance online. We develop new laboratories for distance learning, and I want to finish my speech with a short video how we provide the online learning, blended learning in our university.
Дякую.
thank you all for attention. Thanks. Maybe question.
Thank you, Marina. That was a very colorful and vibrant presentation, we would say.
Thank you.
So I request Shamim sir to start with the
Yes,
session,
yes,
the
Aina.
QA
I
session.
have only one query. I mean, in distance learning, there is a lack of physical social interaction, which is an important component for any kind of teaching. And also, eye contact is missing, and sometimes you cannot read what the learners are learning, right? So how we can, I mean, overcome this situation, in your opinion? Please explain that one, I mean, within a minute. I think we are running out of time, please.
In our university, we developed an approach to we have a blended mode. We, when epidemiological situation is normal, our students went to university. When it's worsen, we go to online. So we combine online and offline activities for, and we have the social interaction with our students.
Thank you so much. Dr. Neha.
Yes, thank you. So I now call Zulu Yao from UK. He'll present his views on an automatic GUI generation method based on generative adversarial network. This is the title of his paper. I now ask him to start with his presentation and keep the time limit in mind. That's 10 minutes.
Yeah, all right, no problem.
Thank you.
So can you see my screen?
Yes, we can.
Okay, yeah. So, thank you very much. And I'm Shuluya, and I'm currently studying my PhD at Manchester Metropolitan University. And the title of my paper is an automatic GUI generation method based on generative adversarial network. So I'm going to introduce the background, challenges, and the aim of this project, and I'm also gonna discuss the experimental results with for each evaluation methods, and there are conclusions as final. So recently, the ultimate generation of graphical user interface design has become a subject of extensive research. Also, deep learning has become a key method to promote progress in this field. But however, it has to be supported by a variety of GUI datasets for the generation process. The UI teams usually adopt an iterative design process to collect feedback on GUI effectiveness at an early stage. So it's best to use prototypes because more detailed feedback can be collected. So we found that the existing works have the following challenges. First, it is very difficult to obtain new data directly because once an image is obtained, it must be manually annotated and classified according to its layout. And these are time-consuming tasks, and that professionals in the field have to perform accurately. So for the GUI structure, objects must be arranged in an orderly manner according to the layout's design specification. So therefore, only a limited number of components is suitable for this approach. Because most of the existing works, they are use traditional methods to evaluate GUI design, which may not reflect the actual results of automatic GUI generation model. So we also need to develop some new evaluation methods in this area. So based on the generative adversarial network, we create a user interface generate adversarial network that can automatically generate a GUI from specific elements as the input. We use the record data set as the reference of the training data and pre-specify a set of fixed element category, such as text, button, and image. So each element is defined by its category probability and the coordinates of each vertex, which are the keys of the bounding box. So the model can then be used for layout optimization because they are specifically utilized to distinguish visual pattern including, but not limited to image segmentation and occlusion. So UI-GAN can generate complex GUI layouts containing multiple objects and relationships. The generator takes the graphical elements of random sampling probability and coordinates value of each vertex as input and arranges the chosen elements in the layout. The component point in the layout are obtained from the coordinates value of each vertex of the bounding box. The output includes the object category and the bounding box of each design elements, which have been chosen according to the sampling probability. The generator has the function of replacing invariants. If the input elements are reordered, this function will generate the same layout. So because the GUI dataset is stored as a basic digital sequence, a layout sequence can be abstracted into a matrix and then further abstract into a vector through the transformation method. So therefore, the layout sequence can be transformed into a matrix or vector through abstract method. When evaluating the similarity between two actions, one must only obtain the similarity of two matrices or vectors through mathematical method. So we use Euclidean distance to calculate the similarity between two matrices A and B with their elements. And then we use cosine similarity to measure the correlation between two vectors. Then we calculate the alpha, which is a combination of two methods to measure the dataset generated by UI-GAN. So to better evaluate the generated image quality, to evaluate the generated GUI quality, we introduce the fractured inception distance score for testing. It evaluates the generation model from two aspects, clarity and diversity. So mathematically, fracture distance is used to calculate the distance between two multivariate normal distribution. Here are the univariate normal distribution. So mu and sigma are the mean and the standard deviation of normal distribution, and x and y are two normal distribution. So FID is given by fracture instance of multivariate normal distribution. So ideally, by the end of UI-GAN training, the generator and the discriminator will have strong correlation and identification abilities. And when the value of one loss function rises, the other will fall until the value in a balance. So from the analysis of the record dataset experiments, it can be concluded that the similarity between the data generated by UI-GAN and original data was higher than that of the vanilla GAN and the original data, because the alpha value was smaller. And the FID score of the generated GUI is about 8.8, which is 0.5 higher than the original, than the GUI data generated by the vanilla GAN.
Last 2 minutes are there.
So yeah.
So
the experiment results return an evaluation value smaller than that of vanilla GAN. so showing that the algorithm improved upon the GAN in the field of GUI generation to a certain extent. So this can be attributed to the fact that UiGAN can learn the dependency between data sequence. So the experiment results also show that UiGAN was able to generate similar GUI datasets. But however, there exists a limited number of object categories in related fields to serve as benchmarks in regards to judging whether the similarity between the datasets created by UiGAN and the original data was reasonable and well generated. So future research is expected to create more elements to generate additional GUI examples, such as extra icon, image buttons, drop-down menus, forms, and the bootstrap components. So thanks for listening and questions.
Thank you. Thank you so much. I have only one concern. Can we, I mean, generate GUI interface for vision impaired people? Because, you know, for vision impaired people, they may not, I mean, sometimes can see the correct color, right? So, in that case, actually, your proposed system can work efficiently or not?
At this moment, so the model can only generate some kind of bounding box with canvas. So as you can see here, the result is still a bit simple, which is limited to a certain categories such as text, image, and buttons. So I think in the future we might have to develop some improve this kind of technology. Yeah.
Okay. Thank you so much.
Thank you very much. Thank you.
Up next, we have the last presenter of the day, Juan Ariola Condori from Peru. He'll present his views on the paper titled Portable Electronic Dispenser for Personal Hygiene in Front of COVID-19. The stage is all yours, Juan. Please share the presentation.
Thank you. Un moment. Can you see?
Yes, your screen is
Bring it
visible.
into full screen mode. Yeah.
Thank you. Good afternoon. My name is Juan Rubén Arreola Condori, and I will present my work title, Portable Electronic Dispenser for Personal Hygiene in Front of COVID-19. Outline, Introduction, Methodology, Results, Conclusion. Introduction.
Can you please go to the full screen mode?
Excuse me.
Full screen. Can you share again?
A moment. Excuse me, a moment.
Juan, please reshare your screen and bring your presentation in full screen mode.
Yeah.
Yes.
That's better. Yeah. You can quickly come to the third slide of your presentation.
Thank you. Good afternoon. My name is Juan Rubén Arreola Condori, and I will present my work title, Portable Electronic Dispenser for Personal Hygiene in Front of COVID-19. Outline, Introduction, Methodology, Results, Conclusion. Introduction. Faced with this problem of the pandemic of COVID-19, this portable electronic dispenser for personal hygiene with voice recognition has been given as a solution. Because when people touch a contaminated object, they are at risk of catching COVID-19. This research will allow us to clean ourselves at the time we want without the need to touch a bottle of alcohol, as it will have a boiling alcohol dispenser which will be attached to the arm, either left or right, and so you can take it to the place you want without the need to carry something in your hand, pocket, backpack, etc. People infected with COVID-19 present
Please move to
respiratory.
the next slide. We can't see you changing the slide. Move to the next slide, please.
Sorry, repeat. Yeah, repeat,
Move
please.
to the next slide. Change the slide. Yeah.
A moment.
Okay.
Yeah, methodology.
Yeah. Better.
Yeah. When registering and verifying that the word said by the user is correct, in the case of this project will be the words alcohol and air. In order to activate the alcohol, yes, or the current respectable in the case of the first sentence. It will activate with a duration of 2 seconds. The foil 5-volt mini water pump that will be located in the nozzle of a plastic container filled with alcohol and will expel intro at in-host. And the case of the second sentence is occurred for drying hands or the place where the device is voluntarily pointed, the user will be activated for a duration of 4 seconds. When registering and verifying that the word say the user is correct, in the case of this project will be the words alcohol and air. In order to activate the alcohol, or the cooler, respectively. This is voice signal when saying the word alcohol. This is voice signal at the moment of saying the word air. And after having carried of this processing of voice signals in MATLAB, we proceed to make a flowchart where it can be seen how the structure of the code that the portable electronic dispenser for personal hygiene will always make. Speed recognition flowchart. Therefore, it was taken into consideration which components can be used for the portability electronic dispenser. Being the scene in a freezing program, we determine the order components: Arduino Pro Mini, battery, charger, MATO, voltage booster, MATO, microphone, MATO, lithium battery, switch, DC motor, 5-volt fan. Consequently, the 3D model was designed in the FreeCAD program with a order of each component in order to have a more concrete idea about the portable electronic dispenser. With this project, the intention is to strengthen individual and public cleaning habits, since it is an alternative or use easy and application with greater resistance and portability for people. 3D model design. Results. When performing the simulation in MATLAB for speech recognition, it can be seen that there is a 1 to 3 second delay for the code to be compiled. When performing the speech recognition, speech training that to be performed to identify the words that will operate the portable electronic dispenser for personal hygiene, which are alcohol and air. This training fields are to be loaded into a math file, and this will be your database. The following are the plots of the fast Fourier transform that were performed on the voice signals. Fourier transform to the word signal alcohol, Fourier transform to the signal of the word egg. And by doing so, the real values were found to the fast Fourier transform of the signals in order to obtain their linear indices by means of a MATLAB function scale find. As can be seen, the values of the indexes of each word are different. The results were obtained at the time of training. These differences exist because they do not have to some tone, frequency, and signal. Since they are different words and also have different sound, to recognize which word it is, we have to calculate the difference between the values of the indexes history in the database and those that will be recorded in real time. And the minimum value of these two is the one that will help us determine which word is inside. The figures show the moment in which the word alcohol and aid are recorded in real time so that
You have last 1 minute to conclude, John.
yes, real-time recognition of the word alcohol. Real-time recognition of the word aid, where speed data of the recording history in a database together with the real-time recording of the word alcohol. For space data of the recording history in a database together with the real-time recording F of the word aid. More recordings were being made to set them in the database in order to strengthen the portable electronic dispenser project for personal hygiene, and when this was done, it was possible and an optimal recognition that reached this in the beginning of the work. Conclusion. The project model developed was very significant to provide a solution of COVID-19 infection, incident zeros and higher level of claims. The general objective, develop an effective voice recognition procedure in any type of environment and circumstance for a portable electronic dispenser for personal hygiene. A signal processing that achieved a real-time voice recognition with a duration of 2 seconds was achieved. Thank you.
Professor Shamim, I request you to bring up some queries if you have.
I think it's okay. I do not have any query.
All right, sir. So we would certainly like to have your special remarks regarding the session.
Okay. So, dear presenter, author, participant, I would like to thank you for sharing your research outcome to the technical session 3E of 7th International Congress on ICT 2022. And we have seen some excellent work on urban traffic detection approaches, cloud robotics knowledge, and we have seen also LSTM-based sign language recognition. And also we have seen two, the very good work which is related to COVID-19 pandemic. And also we have seen GUI UI UX design using GAN, right? So we have seen, and also the session was interactive, and author have answered all of our queries. So thank you so much. And also I would like to thank Dr. Neha for managing this session efficiently. And I also request you to submit your research outcome in the upcoming meeting of International Congress on ICT. Thank you so much.
Good to have you here. I sincerely thank our authors for their excellent presentations in this session and all our participants for being a part of this international conference. I hope this session turned out to be informative and a platform for knowledge sharing for all of us. All the presenters would be getting their digital certificates through emails within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 5 to 6 months, so kindly cooperate with the team of ICICT 2022. I also thank our session chair, Professor Shamim Kesser, for his presence and enlightening us with his wonderful, encouraging words and also kind of inferences that he drew from the presentations. Um, just as a token of appreciation, to you, sir, on behalf of Team ICICT 2022 and Global Research Knowledge Research Foundation, I would like to display the certificate of appreciation on our screens. Thanks a lot once again. I now request everyone to turn their cameras on for a while and also turn on their lovely smiles to capture this wonderful moment, lovely moment together. Let's capture this memory forever till we meet again, somewhere probably in the upcoming conference or some other platform. I think every one of us, I would request those who have not been able to turn their cameras on even now. Thank you so much. Wonderful, vibrant, lovely smiles. I wish all the very best for you all and stay safe, take care. All the very best to your families as well. Thank you so much. Thanks a lot. Thank you.
Thank you.
Thank you.
We
Bye-bye.
are now ending the session. Thanks a lot once again to everyone for their active participation. Thank you.
Thank you so much.
Okay.
Thank you.